So the root test is another test, and it's useful when you have terms involving powers, the nth powers of things. So like the ratio test, the root test is going to look at a limit. We're going to look at the limit of the nth root of the nth term of the series. Okay, and it really gives you this it gives you the same results as the ratio test, except instead of R, we're going to look at rho. So let's look at an example. I'm going to pause here and get an example. And by the convergence test is if rho is between greater than or equal to 0 but less than 1, it converges. If rho is greater than 1, it's going to diverge, and if it equals 1, it's inconclusive. So this is similar to R with the ratio test. And when we're going to use it, we're going to use it when we have the nth power involved in the AK terms. So let me grab an example. Okay, so here's our example. We've got a series where we've got a power. So this is a perfect candidate to use the root test. So let's set it up. It's going to be the limit as k goes to infinity. And I'm going to take the kth root of the term 1 plus, of the series 1 plus k squared. So algebraically, let me switch back to my colors here. So algebraically, this cleans up to 1 plus 3 over k to the k squared. And then instead of the kth root, I'm going to write it as an exponential, which is 1 over k. And this becomes just k. And what we end up with is the limit as k goes to infinity of 1 plus 3 over k to k. When you plug in and substitute in infinity, you notice that you've got something in the terms of 1 to infinity, which is indeterminate form. And hopefully remember that we're going to use the log technique in order to solve this limit. So we want to get it into L'Hopital's rule. I have to pause here. Okay, sorry about that. So we're going to use the log technique, right? So L is equal to the limit as k goes to infinity, and you're taking the log of this, right? So this becomes k ln of 1 plus 3 over k. And we got to get that into indeterminate form so we can use L'Hopital's rule. This was the same exact problem that we have been working with, and that's 0 over 0, so we're going to use L'Hopital's rule. All right. So L is equal to, right, the derivative of the log of 1 plus 3 over k is 1 over 1 plus 3 over k. Use the chain rule, minus 3 over k squared, divided by the derivative of the bottom, which is 1 over k squared. Algebraically reducing this, and you get the limit as k goes to infinity of 3 over 1 plus 3 over k, right? Because these are going to cancel out. You're left with a negative and a negative, so you're left with a positive 3 over 1 plus 3 over k. So that limit, as k goes to infinity, that's going to go to 0, and this limit is equal to 3. So the limit, putting it all together, as k goes to infinity, of 1 plus 3 over k raised to the k power is e to the third, which is greater than 1, and if it's greater than 1, it diverges. So this diverges by the root test. So that's it for the root test. On to the next one.